All right, everybody ready for exercise number 3? Determining resistance through Ohm's Law. That's V equals IR. We are going to put a voltage across this resistor. It's the 100 ohm resistor. Then what we're going to do is measure the current. Then we're going to increase the voltage and measure the current, increase the voltage, measure the current. We're going to plot the voltage versus the current. The slope will be equal to the resistance of this little resistor. And it's a resistor, so we should get a nice straight line, which means it's an ohmic device. The word ohmic means that if you plot V versus I, you get a straight line. Ohm's law applies no matter if you have an ohmic device or not, but if you have an ohmic device, it means that V versus I is linear. So let's start out. It says locate a resistor around 150 ohms. The one in front of me is the black brown one, which is, yes, it's the 101, approximately 100 ohm resistor. Set up an electric circuit as shown in figure 1, and you will need 2 multimeters. One is going to be an ammeter and one is going to be a voltmeter. So let's do that. So what you see is the resistor on the breadboard. I have the power supply, and I'm going to plug the patch cords in using the DC. I'm going to use the DC power supply, not the AC power supply. So I do this step by step. So first I'm going to make one big loop. I'm going to apply power to the resistor. So you've got the red cord going into one end. Then I've got the black. I need a black one. A black cord going into the other end of the resistor. So it's one big loop. Black going into one end, and out the other. Actually, it's coming in this way and going through here in the circuit and out there. So it's one single current. Now we're going to have to put the 2 meters on there. So the first meter I'm going to put in is an ammeter. So over here is going to be my ammeter. And let me move it closer. So notice how I dial it up all the way to the right-hand side. It looks like it's on a squiggly line. And in fact, let's show you what happens if I turn it off and move it all the way over. Unfortunately, the units say AAC. We want ADC. We want to measure amperes in DC, and it defaults to the AC. Notice how A has a white squiggly line on it? That's the default setting on the meter. The yellow one above it is the DC setting. So guess what we have to do to get it to DC? Yeah. There. Now it says ADC. Now the patch cords have to be a different spot than for a voltmeter. See, you have volt, ohms, and that's a diode. There's no amps in there. There's the amps. So you got to put the red plug into the amps, and we're using the 10 amps. So although it probably would be okay for the 400 milliamps, but probably the fuses are blown in those. Then the common one. Now on the other side, I have my voltmeter. So this one, the volts actually are split up into VAC and VDC, so you just have to dial up to VDC. And the V with the steady line. You can see the units are correct on that one. So what I'm going to do now is hook the ammeter. The ammeter has to be put in series into the circuit. So how are we going to do that? Well, if you want to measure the current of something, you have to put the right in the current. So what I have to do is take off one end. So I'm going to take off this end. So now I'm going to run this lead right into the ammeter. So that's going to the positive part. And then the other end of the ammeter is going to go into the resistor. Okay, it took me a while to do that. Oops, it didn't get hooked up. So let me show you what I did. So this black cord goes into the ammeter. Oops, and then out the red cord goes over back to the DC power supply. So what I did is I put it right directly in the circuit. Okay, my ammeter is all set up. Now all I have to do is put the voltmeter in, and that to do, all you have to do is stick them on parallel to it. So, oh, rats, I don't have a patch cords on the left one. It's okay. Okay, I have to use a different alligator code. Oh, and this one, though, has a patch cord on it, so I'm just going to. So what I did is I put one end of the voltmeter across one end and the other end across the other. Now I'm going to go turn on the power supply. And I should be able to read off some voltage. Oops. So 7.67, and look, that's very close to that one. And I have, oops, 0.081 amps. Sorry, you don't have to record that yet. I'm just making sure that it's set. I'm the instructor. I'm checking the circuit like it says in the exercise. Okay, so that's number one. Number two, turn on the power supply and apply a total of 1 volt to the circuit. Okay, so let's go and put 1 volt in there. So right now it's pretty high. I'm going to use this one. I'm going to move this dial down until I get to about 1 volt. So 1 down. And notice this has actually got 3 significant digits. Oops, that's too far down. 8.99. That's close enough. Now let's look what it says on here. 1.0 volts. Let's look what it says on this meter. 1.040 volts. Which one is more precise? That is correct. The meter is more precise. It's 100 times more precise because it has 2 more digits. So 1.039 will be our first voltage reading. So go to data table number 3, write down 1.039 for the voltage, and 0.012. Okay, 0.0125. It's flicking between 2 and 3, so it's 0.0125 for the current. That's I. Okay, I represents the current. See that in the data table? Then, if you look at your procedure, it says increase the voltage by 0.5 volts and record the current again. Repeat for 6 more voltage readings. So we got the first one. So what we're going to do is go up 0.5 volts. Ooh, that's a little bit too much. Oops, it's a little sensitive. It doesn't have to be exactly, so as long as you get that, but it actually makes it easier plotting it if it's close to 1.5. So let's leave it at that. 1.513, and the current is 0.017. You can see, read it off. So that's your second pair. So now let's actually go down, and I'm just looking up your data page to see how many more I have to do. Go up to 2. All right, that's good enough. 2.046 volts, 0.023 amps. Now you can see that the current's going up along with the voltage. Since this is the resistor, it should be linear, and it will be when you plot it out. So that's the third pair of voltage versus current. And by the way, you can see the third column in the data table. How would you find the resistance if you know the voltage and current? If V equals IR, then R will be equal to what? Write down V equals IR and then solve for R. And that's how you find the third column in that data table. So let's go up to 2.5. That's a really tiny bit of adjustment. All right, 2.514. Okay, so what is the current? It is 0.027. Okay, yeah. That's the fourth one. Let's go up again. We do a couple more, and then we're done with this exercise. 3.097, and read it off. Can you read it? 0.0335. It's flicking between them. So if it flicks between them like that, I half it. So it's 0.0335 amps. And again, up. I have a couple more to go. 3.507. We got to get really close that time. And 0.038 amps. Okay. Up again, up again. Oops, cool. 4.032. 0.043. I think that's it. I think I filled up the table now. I've got 1, 1.5, 2, 2.5, 3, 3.5, 4. So that's it for that data table. Now, let's look at the rest of data table number 3. Equation. It says find equation of a line. To find that, you must plot the voltage versus the current. So which one goes on the y and which one goes on the x? V equals IR. So something times the x is equal to the y. So you put the I on the independent axis, or the x-axis, and the V on the y-axis. The slope will be equal to the resistance. So when it says experimental value of the resistance per equation of the line, that's the slope. Percent difference between experimental value calculated from the graph and measured value of the resistor. So this was a resistor I measured in exercise number 2. It was, well, you have it in your data table. I'm not going to go back there. So go back and see what I measured the 100 ohm resistor as. It was 98 something. I can't remember what it was. Then you find the percent difference from the graphical slope with that. Okay? And that's exercise number 3.